Hello, my fellow YouTubers. This is Roy back again. Let's go ahead and jump right into it. I think last night I put the wrong graph up on the magnets. I made a couple different ones, and I figured tonight I'll get a little bit more precise in line with the magnets themselves. So this is cardboard paper, and we'll go over these, and you can see that I got some pull strength here. We'll check and see. We got south here, we got north. So I got that labeled north, and then I got south, north, south, then north again. And we'll talk about these right here. These are the force lines. So everything's moving this way. Over here is moving that way. And the reason it is moving that way is because north always chases south. So if we were to use the right hand rule, and we would go like this, my thumb would be the current, and the winds would be turning this way. So you can look at, I made a little arrow there to show you the spin on that direction, okay? And then on this side, you can see it spins the opposite way, and you can see the flow is this way, because with the right hand rule here, you'd be going like this, and you can see we're spinning counterclockwise, and this we're spinning clockwise. So this is a really good kind of little footprint here to kind of look at these magnets and what about these magnets, okay? You know, it's like a pretty cool wheel in itself, and you can see here these flux lines give a spin, because these flux lines here are pretty deep too. I mean, you got 5 rows here. So these are stacked right on top of each other, so they're touching. When I do stack them on top of each other, they sort of oppose each other, and they want to slide off of each other. So that to me would stretch out the magnetic fields to separate the I guess the swath of the magnetic field to make the field stronger, is what I noticed so far. And you know, unlike a bar magnet, which this would be the front one pole, and then back here would be another pole, you would have here just comes all the way back around. Now it's on this side. So you would have kind of half a toroid, in a sense, of matter, and then you got the substance inside the matter, and then you have the substance creating the other half of this toroid. It's pretty interesting in a sense to look at it that way. Another cool thing I wanted to show you guys is going back to the graph here. So you can see that north is always chasing south. So around the whole wheel, you'll have your north just always coming back in and going in. Then you can see your energies flowing all towards the south, going in on the south. What I like about this is you got your rotation, your spin, your direction. So you're moving this way, going in, you're coming around, and you're going back in. So now this becomes a wheel. What did I do with that little sucker? I had a little piece of PVC. Oh well. Well, this becomes a ball, a wheel in itself. So it's a wheel, and it's turning. This one's turning clockwise. This wheel's turning counterclockwise this way. So you got these little balls, magnetic balls around the whole wheel spinning. Just a visual for you guys to leave your comments, okay? And now on the inside, something unique I noticed here is when I put a magnetic field on this coil, this right here is just iron, right? It'll stick to this because this constantly has because it's steel, it's hardened, it chose its poles a long time ago. So being inside this right here, right now, this coil is banging North Pole right here. So it'll have that stick, but the back of these neutrals, nothing. It don't do anything. So what I'm gonna go ahead and do, show you this first. So, as far as we're gonna get the wheel turning, I think is probably the most important thing to do. Is get the wheel spinning on its own, without a doubt. Get the wheel spinning, and we'll check and see how much current it takes, how much voltage it takes, and how much we're using. Then what can we get back out of it? Power in, power out. Okay, we'll just go that route. We'll just have something to do with it, okay? And then we'll dig deeper in some theories and stuff. But for right now, check this out. So basically, I'm going to go ahead. I have the PMH hooked up to my DC power supply. So let's go ahead and just turn up. I'm going to turn up about 2 volts, and we're going to watch this wheel get pulled to the PMH. See that? All right, it's about 2 volts just did that. Now, if I want to yank the wheel, I would go up, and you can see the wheel right now. Right now we're at 9 amps. Let's turn it down to where this is where it makes the wheel move. About 2 volts, 2.6. So you can see it's just small though. So visualize this. Once you get this wheel moving, that it would take less power to move this. You got it? You can see how responsive it is. Pulled away from a direction. Pulls right back to its poles, opposite poles. I'm going to pull it almost over to the metal. At some point, metal to metal is going to try to pull. I'm so close to it, and it ain't doing that right now. So I'll just nudge it just a little bit. Here you go, look. So it's got a good pull to it. Now let's turn it up a little bit. We'll put 8 volts, 9 amps. You see how responsive that is now? It's gonna be fun. So we'll get the wheel turning. I'm trying to figure out the best pilot system for this wheel. Age and everything. Just something simple. Nothing I'm buying in the store, something I'm gonna make. All right, so let's go ahead and turn this down. All right. Turn power off on that. So you can see the turning this wheel would be no big deal, and I think we're going to use 2 of these. And now we're going to power up the inside. So we're going to go with the right-hand rule, and let's go ahead and put the negative to the start. Now from the center, and this is going to be a little different, we know why. I can't touch the damn magnets with this. Bada bang, bada boom. All right, let's go up to about 7 volts, 3 amps. Strong magnet here. But watch this. Now all of a sudden, on the neutrals, so I would say there's a field that's in here now that wasn't there before. And now these magnets here are balls, and they're spinning clockwise, counterclockwise, and this whole thing is a ball. Okay, you got this iron running 90 degrees off of the ball, basically cutting through the ball. So that these two rings here that are isolated from each other are choosing different poles, to tell you. And then now you can see in here that this has a field inside that I never thought about that would be inside here. Now the magnets on the inside that are neutral are, why isn't this thing sticking over here? Will it stick over here? Yeah, it'll stick to it. Okay, like it should. I just took it out of my hand. Strong there. But with all that going on, how come over here how come that could happen? On the neutrals. Riddle me that, Batman. Leave your comments. I wanted to give a shout out to my boy Honda. Man, Honda, thanks for calling me out on that. I didn't even notice. That was definitely a different template for something else, because there was some insies and outsies. See how I turned the power off and that piece there just fell. So the field in here suspended this up, but it became a magnet to the back of the neutrals. Pretty interesting stuff. But Honda, shout out, my friend. Got it fixed, right? You got this time. Alrighty. Got some good things we're talking about. We'll just stay focused, and we'll direct. The directive right now, goal number 1 is get the wheel turning off 1 or 2 PMHs, and then start a battery of different things based on RPMs, frequency, speed is what I'm talking about. How fast or slow we turn the wheel. And we're not just going to treat it like a rotor or a stator. All right, you guys. Peace out.